Peace be with you, my Algebra 2 students. This is that video I promised I would do with you, and I'd like to be very, very clear on this. So let's ask God to guide us. Father, I ask your guidance, your insight in every word, everything that's communicated. May it be done with clarity, and may it be well understood, and may our students take it, practice, and be as prepared as possible for their upcoming test tomorrow. Here comes number 9. A sprinter now runs a 40-yard race against the wind. So here's a clue word here, against the wind. In the same time it took him to run 60 yards assisted by the wind. And here we see also this word time in there. So that's going to be a clue for us that we're going to be using distance equals rate times time. That's that type of question we've got before us. It says if the wind speed is 2 yards per second, what was the runner's speed? Okay, some mistakes in here, sorry about that. Okay, so again, it's good to read it a second time. A sprinter runs a 40-yard race against the wind. So the wind is resisting him here. It took him 60 yards to run assisted. The wind is helping or assisting him here, pushing him faster. Wind speed is 2 yards per second. What was the runner's speed in still air? All right, so we'll just think of the runner running like this. This way, let's say this is assisted. And when he's coming back this way, he's resisted. Which do you think would be the add and which would be the subtract? I'm sure you got it right. When he's assisted, it's add. So what we can do is we can say let x be the runner's speed in still air. Runner's speed, understood to be still air. And let's say y, the speed of the air current. Might be just a gentle breeze blowing, either blowing against him or blowing in his back, making him go faster. So once we see time in it and we have distance here, we're going to use distance equals rate times time. And let's do the assisted first. When he's going faster. Assisted case is over here. Then we can do the resisted over here. When he's being resisted. So that means he'd be going slower. Alright. The distance when he's assisted, it took him 60 yards. Okay, to run a 60-yard race assisted by the wind. So instead of D here, I'm going to write 60. And since he's assisted, his speed will be faster. X plus y would be his speed, and then times time would be that equation. Now they told us right up front that the air speed, if the wind speed rather, is 2 yards per second. So y in this case is 2 yards per second. So we can write 60 is equal to x plus 2 times the time. Now let's take a look at the resisted situation now. When he's resisted, so when he's coming back against the wind like this, the formula is the same, d equals r times t. But the distance when he runs against the wind is only 40 yards. So it's 40 yards. The rate now is Rx minus Y, because he's being pushed back by the wind, pushing as if we're in his chest, times T. I'm going to write again 40 is equal to X minus, the Y is still 2 yards per second, so it's going to be minus 2 times T. Alright, so here's what we're going to do. I'm going to divide both sides by the X minus 2. So we have 40 over X minus 2 equals X minus 2 divided by X minus 2. So that's what T would be. T would be equal to 40 over X minus 2. And please don't get faint-hearted. Remember, our theme scripture is that with God, you can do well in this. It's not impossible. Over here, we're going to divide also by X plus 2. So we're going to get 60 over X plus 2 is equal to X plus 2 times the T divided by X plus 2. That's gone, so we have T is equal to 60 over X plus 2. Here we have T equals 40 over X plus 2. So what that means is, instead of T here, I can write 40 over X minus 2. So I got in here now 60 over X plus 2 equals 40 over X minus 2. We do the cross multiplication and we get 60 times X minus 2 is equal to 40 times X plus 2. When we do the distributive property here, we get 60X minus 120 is equal to distributive property here as well, 40X plus 80. And then what? Well, we're going to subtract, usually the smaller, so let's subtract the 40x from the right, in which case we have to subtract it from the left. And this becomes 60 take away 40, that's going to be 20. I want to bring it up here. Minus 120. On this side, the 40x disappears and it's going to be equal to 80. This is 120, so I've got the x's on the left. I need the numbers on the right, so I'm going to add 120. This is gone. I have 20x equals 120 plus 80 is 200. Divide both sides by 20. We get 200 divided by 20. This is gone. X equals, to work this out carefully, you should get 10 yards per second. 10 yards per second would be the runner speed. Alright? Well, how about this one? This is the last type I'll be looking at with you. The sum of the digits of a certain two-digit number is 7. Reversing its digits decreases the number by 27. What is the number? Alright, let's go ahead and work it over here. We don't know what the number is, but we know it could be 25 or 37 or 44. So let's just assume that it is XY. So the reversal would be what? YX. Alright? Hold on 1 minute. I'll be coming back. and back. So what do we have? If we have the number xy, the value, this is the second step now, the value of this number is going to be 10 times x plus 1 times y, or times y. The value of this reverse number would be 10y plus 1x. Okay? Now reversing the digits decrease the number by 27. So what can we say? Well, here's what we can say. If the number is decreased, that means the new number is going to be less than the number before. So the original number, 10x plus y, or the value of the original number, is going to bear a special relationship with the value of the new number. Here's the new number, the original number. So the new one is 18 less than the old one. So if I subtract 18, sorry, not 18, 27. If I subtract 27 from the old one, I get the new one, because the new one is 18 less. So that's the relationship we have. And here we're going to put the variables on the left and the numbers on the right. So we can go ahead by subtracting x from both sides. 10x take away x is 9x. The y remains as is. Minus 27 equals 10y. And this x is gone. Next step, we subtract 10y from both sides. Notice we line up y's with y's because they're like terms. And I trust you can understand why. So 10y take away y is 0. Over here we have the negative 27 survives. Over here we have y take away 10y is 9y. And here we have 9x. What's the next step? Next step is we're going to add 27 to both sides. And we have 9x minus 9y equals 27. And notice all these numbers, these three numbers are divisible by 3. So I'm going to take it up here now. And we have 9x minus 9y equals 27. We can divide the left side by 9. I should say divisible by 9. And the right side by 9. So what do we have? Positive 9x divided by positive 9 is an x. Negative 9y divided by positive 9 is a negative x. Positive 27 divided by positive 9 is a 3. Okay? This should be y right here. Okay? And so this is one equation. And here's the other one. The other one we get, it says, reading again, it says the sum of the digits of a certain two-digit number is 7. So the sum of the digits is 7. So here's the other equation, x plus y equals 7. So we're going to solve these two together. You say, how do you do that? Well, we add and we get 2x equals 10. And divide by 2. We get x equals 5. And when we plug this in here, we get 5 plus y equals 7. We subtract 5 from both sides.